Hello everyone. Well, this time I'd like to talk about how to solve the quartic equations. Well, I'd like to show two ways: Paris method and Descartes method. Well, firstly, I talk about Paris method. Well, the equation is as such. Well, ax to the fourth plus bx cubed plus cx squared plus dx plus e is equal to 0, where is not equal to 0. Well, let's divide it by a. So it tends to be this one. Yeah. The leading coefficient can to be 1, and others, the primes are added to others. Yeah. And next, let's make a substitution linear linear expression as such. Y is equal to x plus b prime over 4. Yeah. Then it tend to be this form. Yeah. Y to the fourth plus p y squared plus qy plus r is equal to 0. Well, let's denote by fy. Yeah. And the idea of the Ferris method is as such. We try to express fy as this form: y squared plus t squared minus u times y minus s squared. And we can take square root of u. So this stuff is square stuff. Yeah. So this is the in the form of square minus square. Thus, it's factored as such. Well, so the equation is split into two quadratic equations, and we can solve them. Yeah, this is the idea. Yeah. Well, how can we do that? Well, for now, let's expand. Expand this stuff. Yeah. It goes as such. Well, this is expanded like this. Well, and the coefficient is P and Q and R. Yeah. And from this equality, we have t equal u plus e plus b over 2. And from this one, we have this s is equal to q over 2u. And we plug them into this stuff. And then we have this one. Yeah. and we multiply for u. Then it comes to be this way. Yeah. And this is the expansion. Well, this is the cubic equation on U. So we can solve it by Cardano's method. Yeah. So we can find U, and so we can find T and S. So the idea, well, by the idea, we can find Y. So we find X by subtracting B prime over 4. Yeah. This is the Ferris method. Yeah. And how about Descartes' method? But we go in some way to this. Y to the fourth plus b y squared plus qy plus r is equal to 0. Then the idea is this way. We try to express Fy as the product of two quadratic expressions. So the equation split into two quadratic equations, and we can solve them. Yeah. Well, let's make expansion. It goes as such. Well, this is equal to 0, and this is equal to P and Q R. Well, from this equality, we have C is equal to negative A, and we plug into this stuff. Then B plus D minus A squared is equal to P. So we have this. B plus D is equal to A squared plus P. Okay. And from this equality, we have AD minus AB for C is equal to negative A. AD minus AB is equal to Q. In other words, A times D minus B is equal to Q. And let's make square. Then we have this. A squared times B minus D squared is equal to Q squared. B minus D will do because it's squared. Yeah. Okay. AD minus AB is equal to Q. So A times D minus D is equal to to Q. So the squared A squared times B minus D squared is equal to Q squared. Well, and we plug them into, well, this equality BD is equal to R. But then BD is equal to R. So for BD is equal to B plus D squared minus B minus D squared is equal to 4R. And we multiply A squared. Then it goes like this. A squared times B plus D squared minus B minus D squared is equal to A squared times A squared plus B squared minus Q squared is equal to 4R A squared. Then let's set capital A is equal to A squared. Okay, capital A is equal to A squared. Then we have this from okay, from this part we have this A cubed plus 2p A squared plus B squared minus 4R A minus Q squared is equal to 0. Yeah, this is the same equation as appeared in Ferri's method. Yeah, and we can solve it by Cardano's method. Yeah. If A is not equal to 0, we can find B and D from this and this. See from this, we can have A, B, C, D. We can find A, B, C, D. So from this, we can find Y. So and we can find X. Well, and if A is 0, then from this Q is equal to 0. Then this term vanished. So this is going to be a quadratic equation on y squared. So we find y squared, and so y and x. Yeah. Anyway, we find x. Well, this is the Descartes method. Well, more popular is Ferri's method, I think. Maybe because it's published earlier. But I think Descartes' method is more simple and easy to hit on. Yeah. He gave it in the discourse on the method. Yeah. I'm not sure he hidden this way by himself. Maybe he learned it somewhere. Yeah. Well, and other mathematicians published other ways. That there are some ways to solve quartic equations. Well, anyway, I showed two of them this time. Well, that's it. Thank you for watching. See you next time. Bye.